Alright, let's get started with today's questions. So, our first question of the day is LeetCode number 621, funny number, task scheduler, okay. Given a characters array tasks representing the tasks a CPU needs to do, where each letter represents a different task. Tasks can be done in any order, but each one is done in a unit of time. And for each unit of time, a CPU could either complete one task or be idle. However, there is a non-negative integer n that represents the cooldown period between two same tasks, that there must be at least n units of time between any two tasks. Okay. Return the least number of units that the CPU will take to finish all the given tasks. Okay. Well, there's a corner case here where if n is equal to 0, we can just return tasks.size. And this is because if there's no time delay between any of the tasks of the same type, then we can just really just return just do the tasks in the order that we're given, and it doesn't really matter. Okay, so the task length is 10 to the 4. It's 10 to the 4, which is, let's see, 10 to the second is 100, 10,000, 10,000. Which seems to indicate that this probably should run in O of n time. And actually I'm gonna use O of t time in order to not confuse it with this n. T is the number of tasks in the array. It could be potentially O of tn time, where n is actually the n represented within our input. That's the vibe that I'm getting from the length of the constraint of the input size. Let's see. And the tasks are the tasks in order, given in order. Let's see. I'm thinking, would a greedy solution work? And this greedy solution would be basically create a pointer, or rather split the input array into arrays of individual tasks. So this would be like, we would separate the tasks by the character. And then try to balance the tasks by always picking task of larger size or larger amount, followed by task of, or followed by different task. So this would be like, we take A, then we take B, then we take another A, then we take C, take another A, then D, and so on and so forth. So if we did that actually, let's see. If we took A, so let's see, A. Right, there's 1, 2, 3, 4, 5, 6, and then there's 1, 2, 3, 4, 5, 6, right? So we did A, then B, then A, then C. Or can we not do that? No, we have to do, we have to take the, okay, so we have to take the cooldown regardless. It's not like, just between tasks we have to idle twice. Okay. Let's see. Task. So we have to take a different one for these two. Let's see. What would be the naive solution to finding this? I'm trying to think. Just the naive solution. What would it be? We would take A. Ideally, we'd want to always take the longest cooldown one. Or, no, not the longest cooldown one. The largest size one, right? To always take the largest size one. So we take A, then we take B, then we take C. So the idea is that we keep on taking different letters until we hit the cooldown, and then we go back to the front, or until we go back to the next letter. But we know that each one will be an uppercase English letter. So if we only have uppercase English letters, we could probably store the frequency in an array. So that would be O of 1 space. Okay, so we have O of 1 space there. You would check each. So first fill the array, which would take O of t time. Then iterate over the array. Let's see. How would we handle this? Pick the largest, or the task with the most items. That will be the first. Then pick the second most. Then pick the second most. Is there a way that we could speed this up with a heap or sorting? Because the idea is that if we pick the task that has the most, then the second most, then the third most, and so on and so forth, until we hit n, where we go back. Well, let me think. Assuming that we pick one or from each bucket for each iteration, the item with the most, tasks will always remain so. And what I mean by that is that if we have bucket A with more elements than bucket B, then in that case, then even if we take one element from A and one element from B, well, we'll still have a size of in A that is greater than B, right? And then continue until we run out. And if we iterate through the entire array without doing anything, do an empty task. Or without, doing anything. Then we just do an empty task / idle. I think this works. This sorting, okay, let's see what happens if we try to sort. Now I'm thinking, okay, so we have a max heap. Pull the element, which indicates taking. I don't think that'll work. The problem that I'm facing right now is like, how do we know if we've encountered an element before and we can't quote unquote flush the buffer yet? Well, we could probably use a set that resets on every iteration. Like every time we hit n, we go back to the beginning and then we flush the set essentially, in order to, and the set basically keeps track of the letters that we've seen so far. Okay. But, the second problem is, how do we keep track of not the elements that we've seen, I guess, how do we make sure we grab the most frequent element each time? I think this leans towards a heap still, but we could try to use 2 heaps, though I don't think that's necessary. We can put the heap in there, store the heap inside the map. So rather than here, we do a map, then heapify or re-heapify each time. So the idea is that once we grab an element from our max heap of frequency, we will store it within the map. Then, after we've gone through the entire array, let's see. I'm not actually sure if we need the map, because if we hit n, so if we hit n, then everything is okay to take again. If we do not hit n from the most frequent element, then we need to idle until n, no matter what, if we are at the end of the array. Right? Because if we've gone through our elements and we did not hit n from the beginning, then we need to continue to idle until we hit n again. In that case, I don't think that we actually need a map. Or we don't need... Do we need... We need a heap for sure in order to keep track of our most frequent elements. We can use a map to keep track of our most frequent elements. And then what else? We move them to somewhere else. We need to pop them from our heap and then move them somewhere else. Into a set? Like just like a random set? We could do that. Would that be efficient? So if we run through this, we would need to... Okay, so O of t time would be to fill some data structure. And let's say that because we only have 26, at most 26 elements within our heap, and that will not grow with the size of our input, then we can safely assume, or then I think we can assume that our heapify will take constant time to do so, to run, because we can have at most 26 elements no matter the size of our task. However, we need to reheapify this each time. And suppose that we have a really, really bad case, then what would be the runtime of this? Like if we had a really bad case where we just had to pull all the items, so all 26 items, then requeue them, then pull them all again. We would need to run it at the very least. We would need to run it t times, right? Let me think. This time complexity should not be difficult, but I'm not sure why I can't think about it. So if we pull all the elements out and then we reheapify it, And each of those I think is technically n log n. It's log linear, but we consider it as constant time because there are only 26 possible elements within our heap. I'm not too sure, actually. I'm going to think about this a little bit more. But I think for now, we could probably jump into the code and let's see if there's something that we've missed, right, along the way. Well, let's first tackle our corner case and say if n is equal to 0, return task size. We can say frequency heap is equal to heap, or it's a priority queue of int, I think. So what do we really need to store? We don't really need to store, we don't need to store the item itself within the heap. And that is because when it comes to storing items within the heap, we only need the frequency because each element takes the same amount of time. However, the problem is that when we iterate through this array, there's no guarantee that the tasks are in order, right? So let's assume that they're not. So let's start by building a frequency array, and then we'll heapify it afterwards, right? So that way we know the frequencies of each. So in this case, we'll say frequency array is equal to int array of size 26. Then task for each task, frequency array at task minus capital A plus plus. I think we can just do that. So build the frequency array so that we can keep track of which character it belongs to before heapify. And then we can say frequency array for each item. We can say frequency heap dot add item. So now we just have a bunch of items in here. We can make this more Java-esque with Pascal case for the fields. Now we want to say var task length starts at 0, and this will be ultimately what we'll return. Okay, and then let's see. Task length is equal to 0. Well, what do we want? Well, I think we can say while frequency heap is empty. It's not empty. Then we want to say we'll create a frequency, like we said. We'll create a frequency set to move the items into. Set to keep a hold of items that we have gone through. So while this is not empty and our frequency set is not empty, so while either of them have items, we can say if our frequency heap is actually empty, so this should actually be an OR statement. So if our frequency heap is empty, so heap is empty, that means that we've used up all of our items. And we can say if task length mod n is equal to 0. Otherwise, while task length mod n is not 0, task length plus plus. So this is the idle until cleared. Otherwise, or actually, I don't think we actually need this because we'll flush the buffer or we'll flush everything back regardless, right? So we can say here frequency set for each item, frequency heap add item again. So just re-add all of the items because they are ready to be used. Okay, so that's if the frequency heap is empty. So then we move. First, we idle until we've hit the number that we need. And then we just move all the items from the set back into the heap. Then within here, we can say val frequency, or we can say top is equal to frequency heap dot pull. So this is a top item, and then we remove it. And then we can say task length plus plus, because we know that each one will take 1 unit of time. And then we can say if top minus 1 is greater than 0, then we can add it into our set, minus 1. And then we just continue this. Let's just do that to make it look like it makes more sense. Or I don't know, it's just to make it look a little bit more appealing to add the incrementation at the bottom. So essentially, while the heap is not empty, or if the frequency set is not empty, well, we first check if the heap is empty. If the heap is empty, then we need to fill it from the set. In that case, we check to see if our task length is equal to 0, or is not equal to mod n is not equal to 0, in which case we've used up all of our elements, but we still haven't reached n, so we just need to idle in the meantime. And then we move all our frequency set items back. Then we take the top item from our frequency heap, and if the item minus 1 is greater than 0, so if there are still items, if there are still items of this type, add them to the set. Because if we have used up all the items, then we don't care anymore, and we don't need to add those back into our set. And then we increase our task length by 1. Of course, we also want to see if task length mod n is equal to 0. Then we also want to do the same thing here. So the idea is that if the heap is empty, then we need to go through this, and we may or may not hit this while loop. But if the task length mod n is equal to 0, then we will make a greedy choice to re-add all the items at that point, even if we haven't gone through all the remaining items. We will just add whatever is in the frequency set back into the heap, and then go from there. So we don't finish every cycle of going through all the elements, all the buckets that exist within our character array. We just go until we can reset for the longest, basically the largest value. Yes, and then because we start at basically the largest value. So I think this works. We just need to make sure that this priority queue, because I believe by default, this priority queue actually happens to be a min heap. Yep. The head of this queue is the least element with respect to the specified ordering. Oh, whoops. I think I misremembered the priority queue runtime. Yeah, it's log n for just adding or removing an item, but n log n if we want to add all the items. So assuming that we have an equal spread of all the items, then that will run. Then we have to go through this not t times. So the log part, does the log part get reduced to constant time? Yes, because there are only 26 elements max within here. But how many times do we have to run the heapify? Well, within here, our heapify really goes until all the buckets are empty, which means that this will run t times. So I think this still runs in O of t time. I could be very much wrong about that. But in any case, I need to create a comparator, or I need to create a priority queue, which is the opposite, which I am not entirely sure how to flip the comparator. By the way, there is a poll, right? Yeah. I think. I think we'll have to add. Is this int a wrapper class around integer? If we do a class int compare reverse, which extends a comparator of type int, and this will override a function called compare, which is a of int, b of int. I just want comparable. And then we can say when A is, we'll just do it manually, so A is equal to B, we'll still return 0. When A is greater than B, and wait, A is less than B. When A is greater, so this is natural ordering, so we want to do a reverse natural ordering, right? So I think we want to do that. And then we want to build this priority queue using that int compare reverse. I think. Let's do print line top frequent element. And then we can say top. And then let's just run something like throw one element greater than in A than B. And then let's start doing a run test. Compare is we need to return int here. Let's see. Okay, forgot the return statement. Whoops. Oh, we could just do an else here. Funny how older versions of Kotlin have this exhaustive else case clause, and apparently this was just reintroduced in. This was just reintroduced in, I think, Kotlin 1.7. Interesting. Are we gonna get a time limit exceeded? Oh, I see. Because we really don't have a way of knowing whether or not an element has. Let's see. Well, if we pop an element, or pull it from the top, that grabs A, and now A is moved into the stack. Next, we pull B, which is 3. We can print line emptying stack or heap is empty. And that adds them back in. Then we do the same thing. I don't understand why we are running into that problem. Because poll should be removing it completely, right? Let's see, let's do some more runs and let's see where it's going wrong. So it should be 4, then 3, then refill. Then 3, then 2, then refill. Oh, interesting. Oh, if item is 0, or is greater than 0. Hmm. 4 and 3, then heap, then 3 and 2, then 3 and 2 repeated again and again and again. So this refills it. This adds 3 and 2 back into the heap, which we see. Then that should move it back into there. And should we do... I think it's because the frequency set remove item. Will this result in a concurrent modification exception? Because we shouldn't be modifying the collection while we're inside? Yep, it will. Is there a way to like just pop an item from a set? Let's see. Well, what we could do is once that's done, we just do frequency set.clear, I think. Because I think the problem is that we're adding the items, like we're adding 4 and 3 into our set. Or 3 and 2 rather into our set. We're adding them into back into our heap. And then we add 1 and 2 to our set, but we never cleared 3 and 2. And since 3 and 2 were added before 1 and 0 or 2 and 1, then we won't actually get the correct answer. Let's see. So 4 and 3, then 3 and 2, 4 and 3. Then we need to idle, I think. Let's see. Well, task length mod n is not 0. So that gets us to 2, right? 1, 2. Oh, because this starts at 0, then this is 1. Or sorry, this results in a task length of 1. This results in a task length of 2. So then here, we actually don't do the thing that we need to do, which is idle. Let's do print time since last, or time elapsed since first frequent item, and this should be task length minus 1, I think is what we want. Oh, this should be print line. And we don't want it to be -1. So time because this should start at 0, right? So maybe like that. Then we can clear that. Not quite. Not quite. I feel like I'm getting close to a solution, but we're just not quite there. Realistically, we want to do maybe this. Maybe it's n+1. Rather than task length -1. Because technically we need to wait 1, 2, 3, right, until the third one. So reached 0, or reached n, or the heap is empty, so we add 3 and 2, we flush 3 and or 4 and 3, flush 3 and 2, flush 2 and 1, flush 1, and then we get 10. Let's go ahead and run this against all the example cases. Looks like we got some incorrect answers. Just the first one, actually. Let's take a look at what's going on there. So it should be 3, 3, flush, 2, 2, flush, 1, 1. 3, 3, flush. Because it's a set. Right, because if it's a set, then we can't do the same thing. So, honestly, what could we just reuse the array? No, because the array will not let us keep track of which items we have and haven't gone through. There's probably a better way to do this. Because this is starting to probably use up like a crazy amount of this is probably starting to use a freakish amount of memory, and this might end up being our first memory limit exceeded. First memory limit exceeded problem. We'll see. Okay, cool. Looks like it works. So let's throw in a submit and let's see where we end up. Okay, cool. Looks like it worked. Not particularly fast, not particularly memory efficient, but it works. So the idea is just that we use a heap in order to sort of store an order of the elements that we've used. I'll definitely check out the discussion section for this afterwards, because this wasn't a very simple problem for me. But in any case, I hope you learned something, and I'll see you for the next problem.